All right. Well, we'll go ahead and get started now. It's just about time. Okay. Let me go full screen. Welcome everyone to the next CS196 lecture. Today we're going to be talking about Python 2. This is your second lecture in Python, and we'll start this off first with some review on Python 1, and then we'll get into the topics for today. And those are going to include writing code what we call Pythonically, or in a way that Python supports, and in a way that follows the conventions of Python. We'll talk about list comprehensions, which tie closely into writing things Pythonically. We'll talk about enumerations and enumerate, the function. And then we'll do a little bit of discussion on data structures for sets and tuples and dictionaries. Don't worry too much, we're not CS225, so we're really just going to introduce these so that you can get a general idea on how you can use them and how you may be able to use them in your projects. So first, I want to mention some stuff. Groups have started, so we've done Project Kickoff. Have you been checking Discord? There should be a lot of discussion in there between you and your group. Ideally, the different Discord channels that your group are assigned are really very valuable to keep that conversation going. And so we really do want you to be talking about ideas. Usually, right now is the big thing. Your group has probably had your first group meeting by now. If it hasn't, there's a chance that you missed it, so make sure to check Discord and reach out to your PM if you haven't already. And then additionally, we were going to have the MVP, the minimum viable product, due this Thursday, and we're extending that over to the weekend. We think it's really important, and a lot of teams meet on the weekend and weren't able to finish it this last weekend. And so we want everyone to be able to take a little bit of extra time to refine their project ideas and refine their goals for this semester. So make sure to make use of that. Sprint 1 is still technically starting this Thursday, and so there'll be a little bit of, you should want to get started in your next meeting as well, ideally this weekend. But we're giving you a little bit of extra time to finish up that MVP. Um, I'll talk briefly about the course in general right now. So the groups have started, and obviously we're kind of in full swing with the lecture, which is very nice. Um, the workload will start to pick up a little bit now. We do want to remind you that we're not looking to grade harshly. Really what we're here for is to give you a good understanding of the topics we teach, and not to have you worry about your GPA. And so if you look at past distributions, we grade very generously, and we don't plan on changing that. So make sure that you're really here to learn is the important part, right? The stuff like Prairie Learn, that's really there to make sure that you're actually putting these things into practice. Stuff like groups, again, making sure you're putting stuff into practice and getting experience in kind of a group project environment, which we think is really important. So as long as you're participating in this class, again, we really don't want you to worry too much about your GPA, and probably shouldn't. We're hosting another social hour after this lecture. I'll be a little bit late to it probably, but I encourage you all to attend. You can meet your fellow classmates, you can meet your fellow PMs. We can talk about anything, school related to generally not school related, just how's life going, how's life on campus. I'm not on campus, but I believe it was really cold there recently. So hopefully everyone is okay from that. I'm not sure how cold it got. All I know is it got very cold. Okay, so we'll go ahead and get started with the review now. So first, last lecture, we talked about variables. And so Python doesn't really need you to specify a type with your variables like you do in Java, which I'm sure you're learning in CS125. Rather, you just kind of tell it what you want, and it figures out the rest. So you can say stuff like x equals 4. It understands that that's an integer, and it will assign that to it. For y, you can say y equals a list of 1, 2, 3, 4, 5. It'll understand that's a list. And lists can have different types in them, but in this case, it's just a list of integers. Additionally, we learned about conditionals, and so we have equals equals to compare two values if they're the same. If the two values are the same, it will return true, false otherwise. Not equals does the opposite, so true if they are not equal and false otherwise. We have the greater than or equal to, less than or equal to, greater than or less than, which sound like what they sound like. Usually these are done in numbers, but we'll actually learn a little bit next lecture. We'll talk briefly about how you can do this with sometimes different things. You can use and or to chain conditionals together. And that looks like this. So if x is greater than 0 and if x is not equal to 5. So this would return true if x was equal to 4, but not 5 and not -1, right? If x is less than 190 or greater than or equal to 196. Okay, so next we talked a little bit about loops. And so in this example, we'll look at a given list and we'll say for I in range length letters, print letters. So the length of letters is going to be 5. The range is going to give us 0, 1, 2, 3, 4 when we iterate over it. And then we will index each of those one at a time and print the letters one by one. Another example of this, yeah, we get that a lot. We try to make the distinction. Hopefully, as you learn both Java and Python, and eventually in this class Rust, um, don't forget your semicolons. We're hoping that languages become more of just like a more easy thing to move between, and that does happen as you learn more languages. So let's look at the difference between these two. In this one, we iterate over the indexes in letters. In this one, we iterate over the actual elements in letters. Really, the only fundamental difference between these is in this top loop, you actually know what index you're on, so you know what index I you're at, if you're at the 0 or the 3rd or 4th position. If you need to use that for other things, then it's usually more valuable to do it this way. Otherwise, you can just iterate directly and say for letter in letters, print letter. Both of these are fine. The second one is, again, what we call something that's a little bit more Pythonic, and we're going to talk about that, really, what that means in a little bit. Additionally, we have functions in the production quality I did for this slide and only this slide. So first, you have the function declaration, which you use def for. Next, you have the name of the function itself. So this is what you actually call when you want to use this function. And this can really be anything. There's some exceptions, but largely anything. I know, right? Matt mentioned that he started to get fancy arrows, so I had to get my fancy arrows before he got fancy arrows. Production quality. Oh. The next whatever is the parameters to the function, and so this is whatever you want to pass into this function. In this case, we're passing in two parameters, first num and second num. We're kind of assuming these are numbers here, but they can be, lots of things can be in the parameters. You can pass 3 things, 2 things, and we'll talk again next lecture about some special stuff you can pass in here. And then finally, we have the return here. You don't always have to return things from a function, but generally you want to because it's abstracting away some work and making your code more organized, and you probably need to continue that work somewhere. And so this will return, in this case, the sum of the two numbers. Wonderful. Quick reminder, Python uses lists. Lists are not arrays. You guys are learning Java at the same time, so it's easy to get the two confused. They're not. Lists are mutable. Arrays are not. And so some examples of that is, and some examples of list functions for that matter is this. We'll say, 1, 2, 3, we'll append appended. That'll give us 1, 2, 3 appended. We'll insert at the 0 index inserted. So then at the 0 index, we have inserted. We can sort. And then we can insert into the 0 index again, inserted. Great. So I'm going to wait here for just 1 second and see if anyone has any review questions. Otherwise, we'll continue with the lecture. And again, a lot of this stuff we really do expect for you to put into practice in the homework and get a solid understanding with it. Python's one of those things where, I can lecture about it as much as I want to introduce the bigger picture concepts, but until you actually start writing it, it's hard to sometimes get a fundamental grasp of it. How does sorting a list work? That's a little bit of a broad question. It depends on how you implement the sorting algorithm. There's also, I'll say, different ways to sort, like different ways to sort a function that will all return the correct result that have their own benefits in terms of speed or memory usage. In general, what I do is Google sort list Python. I'll have to look into that a little bit. I'm actually not as familiar with the built-in dot sort for lists. Yeah. A lot of the time when you're using lists, you sometimes have to build a little bit of a special sorting function for whatever it is you're doing. Okay, let's get started. So first, I mentioned this thing called Pythonic code and writing Pythonically. Um, this doesn't really mean anything other than writing in a way that Python was intended to be used. You can write Python however you want. There's no necessarily wrong way of coding. There is ways that are easier to read, easier to write, and easier to fix if things go wrong. And so, there might not be a wrong way, but there's probably better ways, right? Having your code be easier is generally better, is what I would say. And writing Pythonically, especially when you're writing Pythonically in Python, definitely allows for that. Python's a really beautiful language, and it's a high-level language, which allows you to do things probably much more briefly than you would be able to in other languages. And so let's look at some examples. Let's simply see if we can find if something exists in an array. And so first, we'll do this in Java. We'll make our array list. I haven't done Java in a while. We'll check the string that we want to see if it is in the array or not. We'll have some Boolean found value as a flag, and we'll iterate over the elements in the list one at a time. And if one of these values equals the value we're looking for, we'll set the found flag to true. We'll directly translate this into Python. So this is basically the exact same. We make our list, we make the thing we're looking for, the found flag, iterate over, if they're equal, found is true, right? But there's actually a much more brief way and a much more easier to read way to do this in Python. Or to do this Pythonically, I should say. Both ways are valid. Instead of this, production quality, we can do this. So we have our fruits here, apples, oranges, bananas, grapes, and we actually just can use this in variable, or this in operator here, I should say. And so we can say cherries in fruits, right? Can you write Pythonically in other languages? I guess. You shouldn't. Please don't. In a case like this, you probably couldn't. I don't think any other major languages have stuff like in. I could be wrong about that though. So in this situation, we can say just cherries and fruits. That'll return a true or false, and it's much, much easier to read. And so this really allows us to write much more readable code, which is kind of the goal, or at least a goal in Python. We'll give another example. So we want to sum all the numbers from 10 to 100. We create our start and end variables. We create a total sum. We iterate over, and we sum as we go. We'll translate that directly into Python once again. Start and end, total sum, while loop, iterating over. So then how can we do this Pythonically? Well, we can use this stuff called range and sum. We saw range earlier when we had range length, right? Range will give us a range from 10 to, in this case, 1,000. Remember, it's pretty much always non-inclusive of the last one. And then for each element, we're just summing them together using the built-in sum function. And so, in this situation, there's a lot of keystrokes you can save. And if that's not the goal, then I don't know what is. Additionally, this is generally easier to read, right? I would say someone can look at this line and understand it much quicker than the bottom. So some tips for writing Pythonic code is anytime that you think you're about to type a lot or really, typing more than you probably should for an easy task, Google it. We're not expecting you to memorize every single, special operator and way to do things in Python. Googling it is the natural process of coding, regardless of if your exams are open Google or not. Life generally is. So a lot of the times you should probably Google it, and a lot of the times these, more simple patterns that you'll be following, the simple tasks, you're just going to memorize. So one easy one that we'll see is, reversing a list, right? We can Google reversing using slicing. And if you remember, we can say like 2:4, and that'll give us the second to fourth indexes. Well, you can also do ::-1, and that just automatically reduces or inverses the list. Reverses the list, I should say. So remember, writing Pythonically is really just a tool. It's a way of writing things. It doesn't really mean anything concretely. There's no formal definitions, but really what it is making use of the things that Python has given you, right? So that in operator, array slicing is a great example, and it oftentimes leads to your code being more readable and more English, I will say. And a great example of this is list comprehensions. And so list comprehensions are this great Pythonic tool that allows you to create new lists from any other lists, and you can basically read them, which is wonderful. So let's look at what you would do to square every element in a list. So let's say we have a list of numbers and we want a new list that is the square of each of those numbers. First, we'll do this without list comprehensions. We have our first list. We need to create a second empty list. We'll iterate over each element in our list. We'll append the square of each element to the new list, and then we're pretty much done. It's not necessarily difficult to do this. It maybe is a couple lines and a lot of characters, but it works. Another way to do this is Pythonically, or using list comprehensions like this. And so we'll make our first list called nums, and then we have this thing here, and this is the list comprehension. And so we say n squared for n in nums, and that will return us a new list, and that's it. And so let's break down what's really going on here. Is first you have the output expression. And so, first we have the output expression. And so we're trying to say n squared, right? We want to return n squared. And when do we want to return n squared? For every n in nums. And so what you can do is iterate over each of the elements in a list and apply some arbitrary function to those elements, right? This doesn't even need to be n squared. You can make your own function that does, super complicated stuff to this, but as long as it returns some value in the end, that'll get added to this new list, right? Additionally, you can make these a little bit fancier by adding a predicate using, those conditionals that we learned about. So maybe we only want to square the even numbers. In this situation, we could do n squared for n in nums if n is even, essentially, modulo 2 equals 0. So let's look at another example with conditional logic. And so we'll have a sentence, the rocket came back from Mars, vowel for vowel in sentence if vowel in A-E-I-O-U, right? And so what this is saying, really, we'll break this down piece by piece. So for vowel in sentence really is saying for each letter in sentence, right? Because we don't know anything other than this sentence right now. And we want to return the vowel, but only if the vowel is in this string. And so obviously the only vowels that are in this string are A, E, I, O, and U. We can count Y. In this situation, we're not. So we're not counting Y, and there's no Ys anyway, so it doesn't really matter. And so what we'll get here is all of the vowels in order from this string. Does everyone understand list comprehensions? These can get even fancier, and so we can have multiple loops. I need to be ready to make a quiz question. I reminded myself. And so in this situation, we have list A and list B, and we want to return A for A in list A, right? So A num for A num in list A. So in this situation, it would just return just each element in list A. Nothing would really change. For B num in list B. And so this is when it starts to get a little bit more complex to think about. First, we take an element in A num, or first we take an element in list A, and we'll call that A num. And then we'll look at each element in list B, right? And for now, we're returning A num for each element in list B. And so we would have this really long list. But really, we only want to return if A num equals B num. So we take an element from list A, we start with 1. Then we look at each element in list B, and we only return the element in list A if A num equals B num. So 1 is not equal to 2, so we don't return 1, neither with 3, 4, or 5. And then we move on to the next element in list A. And so let's do a quick quiz. I will do this. 4. Nice. Okay, so you should be able to look in the Pollbot channel and answer the poll right now. So take a second and answer this. What would this return? 1, 2, 3, 4, 5, 2, 3, 4, 1, 5, or 1, 2, 3, 4? while we're waiting on people to answer, I'll kind of start breaking it down one more time. My headset died, but it's back now. Well, it didn't die. It just turns off when there's no noise coming through it. So for each element in enum, we want to return enum only if enum is equal to bnum. And bnum is each element in list B. So we take an element from enum, we'll start with 1. We look at each element in bnum, 2, 3, 4, 5, and we only return the element in list A if it equals an element in list B. In the case of 1, that never happens. In the case of 2, that only happens with 2. 3, that only happens with 3. 4, 4, and there's no 5. Okay, so in this situation, we would get 2, 3, 4, because what this does is it only returns the values that are in both arrays, right? And so we will get 2 because 2 is in both, 3 because 3 is in both, and 4 because 4 is in both. Wonderful. Okay. So let's look at our next tool right now, Enumerate, or enum. So sometimes when you have a list, you also want to assign an index to the values in that list. And so if you have a list of cars, maybe Kia, Audi, and BMW, we also want to give those an index more easily and have that work with it. And so what you can do is wrap your iterable, wrap your list in this case, in this enumerate function call, and that will return 2 items, I being the index, and food. And so this is kind of, I will say the more powerful cousin of saying for food in foods, or for saying for I in range length foods, and then saying foods I, because you get both, which is kind of nice. Enumerate's pretty useful with loops, but it doesn't always have to be used with a loop. So sometimes you can just turn things into kind of this different format. And so we can say directly enumerate foods and then turn that into a list. And what you get is this down here. You have a list of these things that we call tuples. And we'll discuss tuples very briefly, but really they're just a way of storing data. Very basic. They're like lists, but you can't actually edit them, or at least edit their length or them. And so what you get here is 0 pizza, 1 kimchi, 2 ramen, 3 pasta, 4 hummus. I should have put KBBQ in here. I had that last night. It was very good. Great. So there's tons of ways to do things Pythonically. The more experience we get, the better you're going to get at writing Python code. Until then, just try not to write Java in Python. Usually it's not the most efficient way to do things. Python is a higher level language. Its focus is a little bit further away from classes. So keep that in mind. That being said, we will be learning about classes tomorrow. So let's briefly talk about data structures, but don't worry, we're not CS225. This isn't going to be, necessarily hard. I just want to introduce these concepts to you so that you can get a brief understanding of how you may be able to use these things and why we use these things. Really, at their heart, data structures are just a different way of treating data that allow you to do certain things faster or have your data have different behaviors. And so the first one we're going to talk about is the set. And so sets, important properties are they're unordered and they're unindexed. So when you compare them to things like lists, those are clearly indexed. You can say, I want the first, second, third, fourth position. And there is an order to them. Even if it's not sorted, there is an order, being the, first, 0th, first, second, third, fourth index. Additionally, in a list, you can have 2 values that are the same. In sets, you cannot. Each value has to be unique. Sets are very nice because you can use them very quickly in a lookup table kind of sense, saying is something in this set or is something not in this set. And there's also some useful kind of functions that you can use that relate to the mathematical concepts of sets. And big things like that are union and intersection. And so union says, kind of everything that's in either of these, and intersection says only things that are in both of these. There's a lot more, but sets are generally useful for stuff like this. So we can keep a list of players and say, if we have seen this player, then we can say hello again. Else, we can add them to that set and then just say welcome for the first time. Another application of this could be people visiting your website. And so if you are trying to keep track of users that you already have in your website, maybe using a list or a database that implements a list might not be the best way. A set might be the best way because, again, that lookup time is very fast. And when your website gets millions and millions of views, it could be, really slow to check if the user has visited your website before if you're not doing it the correct way. And we'll look actually more in that example on Thursday. So again, sets are really just a way to store unique values, no duplicates, in an unordered and unindexed way. The benefits are it's very, very fast to say, is something in this set, right? Next, we're going to talk about the tuple. You saw it a little bit when we did enumeration, but we're going to look at it in a little bit more depth. So tuples are pretty simple. We use parentheses instead of square brackets. Their functionality is basically the same as lists, except they're immutable, as well as because they're immutable, they don't have a lot of the built-in functions that lists do. Immutable, again, just means that you can't change them. And usually, I think people treat them as kind of a cheap and easy way to link some things together. And so if you have, sorry about that, if you have some function that returns multiple objects, maybe you want to wrap those in tuple and just have them be returned to one variable that is that tuple, right? Rather than have 3 or 4 or 5 variables. And so in this situation, we kind of have a tuple that says William Eustis. We can print kind of just the string William Eustis by joining them together with a space. We can try to edit the second item by saying William Eustis is cool. But this is going to error out because, again, tuples are not mutable, they're immutable, and so we're not able to change them, and so I guess I'm not cool, which makes me a little sad. Tuples are sad Python arrays? Yeah, well, Python lists, keep in mind. But basically, they're useful, they're valuable, right? They're fast, they're efficient, but they're nothing kind of too crazy. They're useful, is what I would say. They're a good way to treat multiple items like one item, is what I would say, right? In this situation, we have my tuple, which is representing both my first and last names, and potentially many other things. Okay, now we're going to talk about the dictionary, and we're going to spend a pretty good amount of time on the dictionary here, so prepare yourself. So dictionaries. In a list, we can access elements by referring to indices. And so what that looks like is we use the square brackets and we say, index 0, 1, 2, 3, 4, whatever. In a dictionary, we have this concept of referencing keys, and specifically these key value pairs. And dictionaries are also handy because they're very fast when you use them as a lookup table, but they are also not perfect. And so let's talk first about how you create dictionaries. And so instead of using the square brackets like you do in lists, we're going to use the curly braces. And a kind of a key idea with dictionaries is you can get the value for a key using dictionary key, and you can set the value for a key using dictionary key equals value. And so in this situation, we'll create this dictionary down here with Matt being group 4, Jonah being group 6, and Welby being group 3. And then in these examples here, first we'll just print my dictionary Matt. And so the key here is Matt, and the value is group 4. And so what this will print is group 4. Next, we can add a new element to our dictionary or change an existing one, saying my dictionary Tanishq equals group 1. And what this is going to do is it's going to add a new key value pair to this dictionary that has these properties. Additionally, here I could say, maybe if Matt changes groups, I could say my dictionary Matt equals group 3, right? So some of the special properties of dictionaries is that there can only be one value for a given key. So I can't have two Matts in this dictionary. There can only be one Matt. And in fact, if I tried to add another Matt, it would really just overwrite the existing Matt. So the keys have to be unique. Dictionaries are not necessarily ordered. There is an order to them, so if you iterate over them, you will get an order. Generally speaking, I believe that's the order that kind of the elements are added from, but don't rely on this because there's a lot of things that happen with dictionaries that will break that order. And so don't rely on dictionaries to be ordered, please. But we do want to discuss iterating over dictionaries because that's pretty important. So there's kind of three major ways to iterate over dictionaries. There's the default way, so key for key in my dictionary. Then you can use this .values function. You can say value for values in my dictionary .values. And then you can even use the .items function and get a key value tuple. And so we can say key value for key value in my dictionary .items. And so in this situation, if we iterated over the elements with this first way, key for key in my dictionary, what we'll get is Matt, Jonah, Welby. If we do it the second way, value for value in my dictionary.values, we get group 4, group 6, group 3. Again, I'm kind of assuming there's an order here. This order could be changed. The important thing is that the elements are there. And then for this last one, we'll do key comma value for key comma value in my dictionary.items. We would get a list of tuples, and those tuples would be Matt, comma group 4, Jonah, comma group 6, Welby, comma group 3. Okay, so let's do a quick quiz question. Going pretty fast today. We'll take some time to review afterwards. Okay, so the quiz question should be up in Pollbot. Yep, it is. So take some time. What's going to be printed in this question? And closer to the end of this, I'll go down and break it down kind of. Kind of a key property to remember, a hint that I'll give you all, is that when you are iterating over dictionaries, right, when we use this in, it's actually going to return a list, right? In the default case, it'll be a list of the keys. If we use, oh, shoot. Okay, one moment. This should say .values. That's totally my mistake, everyone. I didn't catch that. Okay. So sorry, this one should have .values inside of the parentheses there. That's my mistake. So when we do it by default, it'll return a list of the keys. When we use .values, it'll return a list of the values. Oh wait, should it? I lied. I was right. I shouldn't doubt myself. Lecture building Eustis is smarter than lecture giving Eustis, I guess. So when we do it by default, we get a list of the keys. When we do items, we get a list of tuples of key comma value. So keep those things in mind as you're answering. Okay, so let's look at these one at a time. So we have a dictionary. We're going to add Tanishq to it, and he's going to be group 1. First, we're going to check, is Tanishq in my dictionary? And so when we just call my dictionary here, kind of as an iterable, what it's going to do is return us a list of the keys. One of the keys is Tanishq, and it is the string Tanishq. These two strings are the same, and so we will get true. Now that I've given you all the first one, well, I'll leave the poll open. I'll close it like halfway. The second one, we'll look at group 1. So we'll say group 1 in my dictionary. Well, my dictionary gives us a list of the keys, not the values. Group 1 is a value, but it is not a key. And so this will return false. The next one we'll look at is group 1 in my dictionary.items. Well, my dictionary.items is going to return a list of tuples. One of those tuples is going to be Tanishq, comma, group 1. But group 1 is not the same as Tanishq, comma group 1. One is a tuple, one is not. And so those two things are not equal. And so this is going to return false. And at this time, I will close the poll. Finally, we'll look at Tanishq, comma group 1 in mydictionary.items. One of the tuples in mydictionary.items is going to be the tuple Tanishq, comma group 1, and so this will return true, and we are going to get result 3. So I see some people put 4, and so the big thing with 4 is that, this third line here is actually false, because group 1, while it may be in one of those tuples, is not necessarily one of those tuples themselves, right? Something you may be able to do is do a list comprehension here and check if group 1 is in one of the tuples that is in my dictionary.items, but we didn't do that, and so it does return false. Whoopsies. And then the next part is, these tuples are comparable. And so we have this brand new tuple, Tanishq, comma group 1, and that is actually equal to a different tuple that is Tanishq, comma group 1. Even if they're fundamentally different tuples, as long as they have the same contents, they are the same. Okay. So if you remember we did list comprehension, we can actually do dictionary comprehension as well. This is something that not a lot of people use, but it's pretty useful. So similar to lists, you can do dictionary comprehensions. This is because, of course, you can iterate over dictionaries once you use the default or the dot values or the dot items. The only thing you really need to change is instead of returning the square braces to tell it to return a list, you need to use curly braces. And additionally, you need to tell it what's a key and what's a value. And so let's take a second here and analyze what I've written here. And so we have inverted dictionary equals v colon k for k comma v in my dictionary.items. So let's break this down piece by piece. First, we call dictionary.items, and we're going to get a list of tuples with the key and then the value. For each element in those tuples, so for each tuple, we're going to break it down into the key and the value. Then, in our new dictionary, we want to set the key equal to the value and the value equal to the key. And so what we're doing is we're flipping the keys and the values in this dictionary. And so an important question that I have for you all is, what do we have to worry about when we do this? There's a certain property in dictionaries that means this might not actually work. This could fail, or at least not work the way we want it to. So what could go wrong in this dictionary comprehension here? We're flipping the keys and the values. Can the values be null non-existent? I don't believe so, but you are on the right track. What there was a when you make them keys it doesn't work. Close. So I guess you could actually have a key that is something like null, but you're on the right track. You're very close to something that you probably have to worry about a little bit more, and that is there's a certain property of the keys that doesn't matter with the values, right? They could be null, they couldn't be non-existent, I don't believe. I guess it might be possible if with some like weird memory stuff, like if you allocate something and then delete it without telling the dictionary, some badness could happen there, but you'll get a completely different error if you do that. You're on the right track there. You're very close. And so if we go back, we can remember that there can only be one value for a given key, right? Keys have to be unique. Is this the same with the values? No, of course not. Values can be the same, right? And so if I had two PMs for the same group, which for most groups we do have, those PMs would both be set to group, we'll say 1. Well, what happens is when we do this, well, only one of them is going to exist. And so whichever one shows up second is going to be set to the, group 1 key. And so you have to be a little bit careful about that. when you're doing dictionary comprehensions, especially when you're doing, inverting dictionaries or flipping the values in a dictionary, which is not an uncommon thing to do, you do have to keep in mind that, one of these things is unique and one of these things is not necessarily unique. So be a little bit careful with that. Okay, so the big picture here is Python is a tool that we're going to be using from now on. A lot of the projects that you all are going to be writing with us are going to be in Python. We want to kind of teach you the basics so that you can use it and be fluent in it. And my headset continues to turn off when there's not enough noise. I think it's 20 minutes is the timer. So yeah, we're going to be using Python as a tool, and we just want you all to start to be a little bit comfortable with writing in Python. And again, really the strength, and you say coming from Java, some of these things are confusing. That's true. I don't disagree. What's going to help you a lot is writing code, right? Putting it into practice is really the number one thing you can do, not only to learn new concepts in general, but to learn a language specifically, right? One other thing I suggest doing is really separating the two. So don't write code in the same way, right? And this is kind of one of the benefits of writing Pythonically is you have a little bit of a different way of thinking, and that should help to separate the two. In terms of syntax, you'll actually get used to that surprisingly fast. I give it a week or two before most people here are going to be pretty comfortable with being able to switch between the syntax of the two. Writing Pythonically is, maybe a different thing. Sometimes you will get those confused. I know I do. Syntax is not hard but easy to confuse. Yeah, absolutely. Yeah, I get my print statements confused all the time between, Java, C, C++, who knows, all the stuff. Okay, I'm going to do a quick review, and then if we still have time extra, then I have something. I took some pictures, and so I'll show you guys some of the pictures that I took when I went to Bukhansan National Park. So again, Pythonic code is just kind of the proper way of writing Python. It's generally easier to read and write and fix. There's nothing that is necessarily, the Bible for writing Pythonically. It's more so just using Python's tools to have your code be more readable and more brief. And so a great example of this is, in fact, list comprehensions, as well as array slicing. I'll mention array slicing is so great. I love array slicing. Anyway, list comprehensions is a great tool and it allows you to create lists from other lists. This is incredibly powerful because you can basically have any arbitrary function. Yeah. And then you iterate over the list and you have some arbitrary filter. And so really there's almost an infinite amount of things you can do with list comprehensions, because you can have, any function call here and any function call here, which means you can do tons and tons of stuff. You can have multiple loops, in this case matching the two. We have the enumerate tool, which assigns an index to each element. Again, this returns a tuple. We're just deconstructing this tuple into the index and the element itself. If we had only one thing here, then it would be a tuple of the two items, and we could see each of the two items by just taking the index of that. So, if we say, for tuple in enumerate foods, we could say tuple of 0 equals I, or I equals tuple 0, just like you would index a list. I almost said array. So we have the set. Again, sets are useful for quick lookup. They're fast, they're unordered, they're unindexed, so don't pretend like they are. Everything is unique. Are there any resources to writing Pythonic code that you could toss our way? The number one thing is Googling it. And I know that sounds weird. Again, Googling is like a really awesome tool. That's one of the skills we try to teach you in CS196. If you think that you're going to have to write something in a way that seems inefficient, like there really should not be a reason why it's 13 lines to reverse a list in Java, Google it, and you'll find, hey, it's 5 characters to do it in Python. We also have tuples. Tuples are immutable lists. That's pretty much it. They're handy, and then dictionaries with their key value pairs. Googling is useful, I'm telling you. I mean, it's a skill. It's a skill. Okay. dictionary comprehensions as well, making sure the two things are, replacing the square brackets with curly brackets, setting the key value. Okay, we have a couple minutes here. I think I'll still end a couple minutes early, but I will send you some pictures. And so we went to Bukhansan National Park, which is just north of Seoul, this past weekend. This is the area that we went to, so we went to one of the peaks. It was very nice. We didn't get to the exact top because there was some rock climbing and we didn't have the safety gear, so no one felt like dying. But this is some of the pictures that I took. These are two of my friends sitting on a ledge pretty close to the top. This is a statue that we went to on the way. It's massive, and then all of these are smaller ones. It was very awe-inspiring. I have another picture which gets the god rays going behind it a little bit better, but I was in a little bit of a rush to get these in. This is just a gate that we went to. That's me. Hey, everybody. I liked the light. The light was coming in at a good angle. And then I also have this one, which is one of my more favorites. It was pretty foggy, as you could tell, and so it's a little bit hard to see the horizon. But with the nice trees sitting on a rock looking out, it was very nice. The ocean is way over there. I don't actually think you can see it. It's not this little white streak here. Maybe it's over here. I can't remember. One of these is the Han River. Anywho, thanks all. This is Python 2. Next lecture is going to be on Python 3. We'll talk a little bit about classes and doing some extra fancy stuff in Python. Again, I know I like this one a lot. Again, the major tool of Python is that it's a tool, and so we want you to be able to utilize it for different stuff. You don't need to become a Python professional, but it is a very useful thing to know. So we want to make sure that we're teaching it, and the number one thing you can do is do the homeworks. It'll give you actual experience writing Python code, and that's again the number one way to learn a new language. So thank you all. I'll see you next lecture on this Thursday. Again, Python 3 classes. It'll be fun. Bye-bye.